Hello and welcome to Assessment 3B, part of the Operating System Fundamentals for 2022. So as part of this project, I'm creating a rootkit. So label the rootkit as rootkit 9217 after the subject. I'll start off going through some assumptions and what the project is, how I created it, and then get into a demo and close out. A couple of things with the project. Main goal was to learn about a rootkit, how it worked, how it interacted with the operating system. Second goal was to successfully load a module and take over the system call. So my assumptions I made is that I would not be exploiting an operating system. So I'm going to assume that I already have privilege escalation. I've already got that root account inside the system. So the rootkit is 100% educational. It has detection in place at the moment. So if you scan for it, you will find it. Very noisy in how I'm doing it. I'm using a lot of logging to keep it visible for the learning experience. The other assumption is I'm using Ubuntu and I'm writing the code in C. So how rootkit works. So a rootkit is a kernel module. So it's forms part of the operating system, same as a driver. What happens is when an operating system starts up, it loads a whole heap of modules dynamically into the environment. One of these we will be as a rootkit. Now, these modules allow user mode areas to talk to system mode or kernel mode areas in the environment. So if you were to do an ls command, the ls command would go through the standard libraries into a system call. The system call would then do an IO task to the file system libraries. If you did a ps or a kill command, it would then go through the libraries system call, but down into the process related libraries of the environment around the interconnections between each thing. So how rootkit works. Rootkit loads in as a standard kernel module. So when it first starts up, it loads as a normal module, appears exactly the same. I'll go through a base module soon. It locates the system call table. Once it finds the system call table, it then looks for the address of a function that it wants to override. In my example that I'm working with, I'm using the kill function because of specific values that I'm able to use with it. So what I do is I look through for the kill function, and then what it does is it replaces that kill function with its own function call. Okay, so it takes a backup of it, injects its function address into it, and then when the system calls, it executes the rootkit's function, not the kill function. Once the kill function of the rootkit has finished, it will then send the request back to the original function, or it'll just drop the request and continue processing. Now, if you do everything correctly, it should just show as a normal process flow and nothing should be sent to the user. Now, for the educational purposes of these, once we get out of unloading a rootkit, we want to reverse all the changes we've made. That's why I take a backup of the system tables, because we'll then inject on the exit the original kill functionality call. So with that, let's drop into a demo and start going through the process. Okay, to start the demo off, let's look quickly through the source code. So when I first started this, I started working on a base module just to showcase how it actually loads up. So the base module I've got here uses the kernel mode libraries. So as we said before, the kernel libraries are different from a normal system. When you perform a functionality like a printf statement, kernel doesn't have printf. That's a user mode function. So because we're in the kernel mode, we need to use the kernel mode libraries. That's why we grab specific ones down. Now, to build the environment to do this, first thing I did was create a script which went through and downloaded the necessary kernel mode tools and the headers, and then hooked me up to my Git repo so I can download the code and transport it between the two systems. My base code module loads the standard kernel libraries, sets up the module definition. Now, module definition is critically important. If you do not have a license associated to your module, it will taint the kernel and alert anybody monitoring that you've got a tainted kernel, that someone's tried to inject code into the kernel. Then what happens is you have a function hook call. So these are the same as constructors and destructors in most object-oriented programs. It's almost like a trigger. So when I call the init, that replaces the main function in the C program. It calls my function init and my function exit, which just log information. So this is the replacement for printf. Okay. So in saying that, so standard stuff, setting up the module to make sure it's available. I then load the module and I go into the hook system call first. So from the hook system call, what I do is I grab the system call table, which is here. Grab the system call table. It goes off and looks for it. It uses this module here. This is the reason I was using kernel 4.4 is to use this module. There's a lot more code involved in trying to use the kprobe, which is the method you use in kernels 5 and above. So once I've done that, I then store the system calls. So I go through and I actually grab a copy of where it is. Now I'm using the kill function, as I said earlier. So what I've done is calling into the system call function, and I'm actually recording an index of it. So each of the system call tables are basically a pointer to a number of addresses. So the n_nr_kill is the number record for kill. So it tells me how far down that index kill command is, and I can then grab that address and safely know that that's a kill address. There's a whole list of these ones recorded in the kernel modules, which tells you which one you can do. So once I've done that, I then switch back and I will, from there, perform a couple of smaller actions, which is I'll protect and unprotect the memory. So as we write through to the kernel mode, there is a hook that the hardware CPU has on the kernel, which basically says you cannot perform write protection. So what I've done is a guy named Jimmy has actually already created a set of functions that allow us to turn off this functionality. So I've taken a copy of those functions. You'll notice that it is fully cited. The functions basically just do a binary operation and move a bit on the actual value. So it's actually moving the 16th bit. You can see down here. Okay, so back to the base, back to the call. Once I've done that, I can then inject my hack function. And my hack function basically overwrites the kill process. It overwrites the 3 kill IDs, SIG super, SIG hide, and SIG shell. These are IDs that I've created. They do overwrite pre-existing ones. In the kill command, we have kill things like kill -9, which kills the process or terminates the process. Each of these signals tells the kill process to do a certain thing. So what I'm going to do is going to hijack the 3 of them and get it to do stuff that I want to make it do. To start off with, I've got my 2 terminals up and running at the moment. So I have 2 users that are currently logged in at the moment. So the first one I've got hooked onto my Ubuntu box is a test user. The user has no elevated privileges and is just a stock standard user. The other one is my root account. My admin account has access to the environment. And if you look through the functionality here, I've already downloaded the files for Rootkit. So the first thing we do is we perform a make against the file, recompiles it. Now you'll notice that there are a couple of files created here. The key one to look out for is these KO modules. These are the kernel modules that are up here inside the environment, which goes through the process. So this automatically builds the module for you. And I've included in the bottom of this a few extra commands to help out. So if we first check, we can see that the module is not loaded. Next command is to actually load our module in. Load my module in, do my check, my module is there. So the first action we want to attempt to do is hide that user control. So if we go to our system call function, you can see here I've got the 3 values that we want to test for. So the first one is let's hide it, which is 63. And I perform a kill command with 63 as a signal and send it to process 1. Process doesn't matter because kill will be aborted. It's run, looks like it's worked fine. I go over and check my modules again. My module is now missing. So the next one I want to do is establish a reverse shell. Now to do this, I have created another terminal window over here, which is running an SSH to another machine. I've already opened up Netcat on here, and you can see that it is already listening. Next one we want to do is we want to do a kill 62, which is our root shell command. Fire that off, we immediately get a root shell occurring on the other side, and I can see that I am root. Last thing I want to do is I want to actually get this guy to be a root user. So be a root user, we issue the 64 kill command. I hit go, and now if I check, I am root. The user has full root access against the environment. The last thing to sort of look at is how do we get rid of it? So if I check again, switching back to my privileged user, I can't see the module is there. If I attempt to remove the module, you'll see that it doesn't exist. And this is because the rootkit is actually modifying the module list and removing my rootkit from that list. The next thing we do is just check the log files. You can see the log files in here. It shows that the environment is loaded. You can see the kill commands going through. It's hiding the user. Okay, it did a reverse shell and it gave some user access. So let's get rid of this rootkit now. So to get rid of it, the first thing we need to do is just reissue the kill command of 63 on a process. Now if I check my modules, my module is back. Perform a remove command. It's removed. Check the logs again. I can see that the module has been removed. And that's pretty much it. So to wrap up, final thoughts on the environment. So project was a success. There were some failures and learnings as I went across the line. The Kpro method for the new kernels was one that stumped me for a while. I was probably spent about 1 to 2 days trying to get that working. Got most of it working. It just was a little bit harder to hook into the system calls the way I wanted to. So I switched to the 4.4 kernel and everything's fine. There's a lot of coding, a lot of reading, more than I expected, probably at least 3 or 4 days worth of solid coding trying to get these things working. Now know a lot about kernel modules. So going forward, I will publish a rootkit up for other students on GitHub. I want to continue investigation into the Kpro and start looking at the next gen of these rootkits, and then start expanding the rootkit to additional services. And finally, look at how I can do a command and control type integration into the rootkit to allow me to control it. Thank you for watching.